A magnetic field, which is symbolized by capital B, is generated by moving electric charges. Magnets have a north pole and a south pole, and as you know from playing with magnets as a child, that a north pole and the south pole will be attractive. If you have two north poles of two magnets that are close together, they tend to repel, and two south poles also tend to repel. Opposites attract, like poles repel. The Earth acts like a big magnet due to convection currents in the Earth's molten core. True north is geographic north. True north would be the North Pole. You can see we've got Santa's reindeer up here. True north would be the tip of the axis of Earth's rotation. It turns out that the Earth magnet doesn't have a pole that quite perfectly lines up with the North Pole, or true north. We call the direction a compass points magnetic north. And the reason we call it north is because north poles of our magnets, or the north pole of a compass, will point generally north. And the reason it points generally north is because the south pole of the Earth magnet is up there. Opposites attract. So the north pole of our compass is going to be attracted to the south pole of the Earth magnet. Just to be clear, there is not a giant bar magnet buried in the Earth. This is a make-believe construct that I'm using simply to represent that the south pole of the Earth magnet is quite close to true north. The difference between true north and magnetic north is called the magnetic declination. If you are a sailor, you will want to be well versed in what it means to have a magnetic declination, because depending on where you are, your compass is going to not point generally to true north. It will point to magnetic north, and you need to know the difference between those so that you set your course properly. The magnetic declination, as I say here, depends on one's global location. There's actually quite a bit of math behind these concepts. I'm just going to go through the very basics of the difference between a motor and a generator. A motor starts with an electric current and a magnetic field, and the combination of those two produces mechanical energy, produces motion, produces movement of some kind, spinning of some kind. That's what we mean by a motor. You start with an electric current in a magnetic field and you get motion, mechanical energy. A generator is kind of a motor run backwards. You start with mechanical energy, that is, you start with motion. You start with a spinning, for example. And if you have a coil of wire in a magnetic field that is spinning, you will generate an electric current. Magnetic, i.e. B fields, are generated by moving charges, for example electrons around the nuclei of atoms. Most materials aren't normally magnetic because the B fields of this way moving electrons are exactly cancelled by the B fields of that way moving electrons. Materials like, often, iron, have an unequal number of this and that electrons, and so manifest a measurable B field. With regard to a motor, when a current interacts with a magnetic field, mechanical energy results. With regard to a generator, when mechanical energy spins a conductor in a magnetic field, current is produced.